I sort of so I forgot to push my code from my work laptop for part 17, and so or part 2 of 17. Well, really any of my code for 17 I didn't push, so I don't have that. Um, Instead, what we're gonna do is we're just gonna start working on day 18, and then I may try to re-implement 17.1 to then go into doing 17.2. I would like to be caught up. So here is 18. A program runs this region of memory isn't safe. Pushing whole bytes down on us. Run. Algorithm is fast. Going to cause a byte to fall into your memory once every nanosecond. Okay. Fortunately, you're faster by. No, I'm not. What time is it? It's 6:22. So I'm pretty sure many trillions of bytes have fallen at this point. Your memory space is a two-dimensional grid of coordinates. Okay, so it's just going to be this is val grid equals grid. And can I do something like, I don't know if I've written this. I have not. Okay. So I think it's something like array. What I can do is array size 70, and let's do base dot to mutable list. Does that not work? Oh, array. Can I not do that? Sorry, my son has been extraordinary. Um, Sorry, we're having a fussy meltdown because our son refused to eat dinner, and now he wants to eat, but he won't eat what we're giving him, and that's what having a 2-year-old is like. Mule list car. Can I not? And okay, mutable list. I'm just gonna repeat 70 times. List dot add array I was stuck in Java brain there. Okay. And let's actually just to make this a bit easier to see, we're just gonna do grid list. All right, it's running. It's compiling. So not a good sign. Oh, for fuck's sake. Am I running the wrong file? Okay, there we go. Oh, well. All right, there we go. Okay, so we're getting our grid. And then however, for the sake of okay, so let's try fonts. Well, it's six. Okay. So we have grid size and grid size. Okay. All right. And these are my test inputs. Each byte. I wish the text would rip. All right. Each byte position is given by xy, where x is the distance from the list. So x is the column and y is the row. So I do want to reverse that when I'm reading this in. Um, that was weird. The heck is all this? Val coordinates equals lines dot filter is not empty. What is going on here? Is that just the Windows thing? Okay. I don't know if it matters, but it might. So let's try dot map it dot split on comma. Let's get my real input here real quick. Okay, that's a lot of inputs, but that's fine. And actually, let's do it down here. And the reason I want to do it down here is that what I'm going to do is dot map grid coordinates int 1 to int 0.2int. I'm reversing that because it's Um, it's for me, it's row and then column. So like row and then column is the index. So I'm reversing that. You and your historians are currently in the top left corner. And there's going to be grid dot coordinates dot for each grid set you'll need to simulate the falling bytes to plan out. Chloe, that's enough. Sorry, there's way too much screaming upstairs, so I'm gonna have to be right back. I'll be right back. Yes, this is Kotlin, correct. Sorry, I was getting a little bit of a heartburn episode just from stress. Okay, so oh wait. Okay, they fall every now and then, so I don't actually want to do this yet. Kitten, do you mind? So I don't want to do that yet. Now it's let's do kitten. Relax. Sorry, my Chloe really wants to climb up here. I'm sort of moving away from constantly having all of these, you know, things lying around. I'm just going to start putting them into global variables for the sake of what I'm doing here. Okay, so now from there, part one is okay. What an incredibly bizarre thing that this IDE is doing right now. Okay. Actually, yeah, let's pass it in coordinates. And let's not have that in the global space. Okay. So you need to reach the exit at the bottom right corner, 6, 6 in this example. Plan out where it will be safe to run. For now, simulate just the first few bytes. As the bytes fall, they will make that coordinate corrupted. Cannot be entered. Okay. You'll need to plan your route carefully. You also cannot leave the boundaries of the memory space. Your only hope is to reach the exit. If you were to draw, it would look like this. Okay, so so wait. So it's saying if I only look at the first 12, but like okay, hang on. I'm just curious what this looks like. Okay, so it actually doesn't. So it's not possible to do. I see. I see. Okay, so there's going to be some kind of searching, but right now it's saying do the easy one, which is okay. Just if we were to do 12, so num bytes where we're going to do const val. Actually, no, let's just do val num bytes equals 12. And now it's just a flood fill. Um, so 0 dot dot less than num bytes dot for each indexed actually just for each. What am I saying? Just for each. And we're going to do run, see what it looks like. Yep. Okay, and now it's just doing. I mean, I can do a depth first search. So it would just be equals stack grid coordinate, and then what would it be? Maybe while stack is not empty. Coordinate grid coordinate val path is list of grid coordinate. While the stack is not empty, val next node, and this is no longer stack coordinate, actually, it is node. Push node start list of start, and its next node equals stack.pop. If not yet, let's get the neighbors. So the neighbors are going to be actually the other thing I'll do is I'll do grid size -1, grid size -1. Okay. And this is our goal. If next node dot coordinate equals goal, then return next node dot size or next node dot path dot size. Is that what I'm going for? Is the just the path? Okay. Do I need to do Dijkstra's here? I need to do dexterous. I guess I could do a breadth first search. But I'm going to guess my input's large enough that I don't want to do that. Yeah, fuck it. Let's let it ride. Actually, here we go. Priority queue. Node. And then we're going to prioritize doing, let's say the Manhattan distance. So compare by hit dot pro minus goal dot row. We'll do the Manhattan distance. And then we're going to do, yeah, because I think I want to do Dijkstra's if I want the shortest path. I don't think I want to do a breadth first search. Technically, what I'm doing is sort of a best first search here, but that's basically what Dijkstra's is anyway. Q.add. And then val best distances equal mutable map of node int. Yeah, because even if I have to traverse everything, 70 times 7 is not going to be, yeah. And actually, instead of doing visited, that's what path is for. So we may now have best distances. Oh, right. Okay. The while queue is not empty. Okay. Else we're gonna do next node dot grid dot get cardinal neighbors next node coordinate dot filter not in the path I'll filter not and then for neighbor we're gonna say okay if best distances neighbor if bestInstances dot contains neighbor, if it doesn't contain that, then we're going to go ahead and do next node +1. One distance from that. Oh, next node dot coordinate 1. And then we're going to q dot add node neighbor path plus next node dot path plus neighbor. I think that works. What? The heck is going on? That's what's going on. $13. What? I don't think that's right. Next node dot path dot for each grid dot set it to O. Oh, right, because I'm an idiot, because I forgot that we can't walk through walls. Filter not grid dot get next node. All right, we can't walk through walls. I forgot about that fact. Okay. And 25. Yeah, I just realized that I actually maybe have to do a breadth first search. All right, well. Um, if next node what is it? It's dot size, right? But then I have to is greater than right. Okay. Then break. Dot. Hmm. Hang on. Hang on. I'm getting 23. It's 22. Oh, does start not count? Real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3. Okay. So yeah, start doesn't count. All right. So I think that's. I'm effectively doing a breadth first search now, but no clue if this will be fast enough for my big input. Grid size is now, what, 70, if I recall? Zero to 70. So I need a grid size of 71, number of bytes of 1024. 336. Okay. I'm gonna guess part two is I have to like simulate the full path sort of as things fall. Aren't you as used to moving around in this pixelated universe as you are? You're afraid they're not going to be fast enough to make it to the exit before path is completely proc. Determine how fast everyone needs to go. You need to determine the first byte that will cut off the path to the exit. Oh, that's it. So I just flood fill. So I just flood fill. It's the same. I can even just cheat and use get -1 result, right? Yeah, let's just brute force it. So we know it's greater than 1024. So let me make sure I'm not modifying my grid anywhere right now. Yeah. Yeah, this is easy. I mean, easy to brute force. I don't know if it'll be fast enough, but I mean, what? I only have. So I know 1024 is enough. So something like 10 num bytes plus one. Actually, rather than checking if it's equal to that, I just say like in from 0 to num bytes. It's kind of disconcerting that it added that, but okay. I guess I don't have that. I have to do. Oh, right. It's just next node coordinate. Okay, let's just do return 0 here. Make sure that what I'm doing works. I mean, there's probably a better way to do it. Blood filling each time or just detecting until, I can no longer reach like every point, but I'll just Dijkstra's it, honestly. Just brute force for now. I'm tired, so we'll do num bytes dot dot less than coordinates dot size. Dot for each. Or dot first. And it's just going to be the first where get part 1 result. Start goal coordinates n is less than -1. I'm not saying this is fast, but shouldn't be too bad. Let's just see how fast. Yeah, it's honestly not too bad. If anything, I might want to count backwards. I'm certain there's a better solution. I just don't know what it is right now. I'm too tired to think about what it is. No such element. Hang on. What? I looped through all of them. And there's still a path each time? Yeah. This is just me sanity checking my stuff here. What? 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 Okay. Oh, doi. Less than 0. Herp. Herp derp. Less than 0. I'm an idiot. I am not, what's the word I'm looking for? Capable of thought right now. What I'm trying to say is I'm a fucking idiot. And yes, I am brute forcing it. My thought would be to just do something like, um, what might be faster. I don't know. I'll think about it. There's definitely going to be a faster way to do this. That's not the right answer. What? Squeeze me? Ew. Ew, I have a fence post problem. Wait, no, but that shouldn't be an issue. I shouldn't be having a fence post problem. $21, right? Oh, what is the first byte? I went with the index of, and it would be grid coordinate, and it would be the first. Right. No, I'm not right. Hang on. Oh, that's right, because I'm reversing it. I'm reversing it, so it's going to be return. I know what I want this to be. I'm not getting the right value. I'm going one too far. Is that it? Right. From, and that's exclusive. How am I? I'm trying to figure out how I'm getting it off by one. After adding the next byte, there is no longer a path. I'm trying to figure out if this is an off by one error or if it's a deeper problem. Because if it's off by one, that's an easy fix, but I don't think it's an off by one. Coordinates. Not result. N. And then That would be 4. Row indices. 4 call in grid coordinate row call. If hang on, if C in, that's the actually wall. So let's actually do if it's in best path. Else if C in and then I need to do right. So there's a path here. And then at 21 there isn't. Oh wait. Is this an off by 1? Hang on. I know this is stupid, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. On the 20th, I should be adding this. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why am I counting this way when I could just look here? On the So yeah, the 20th should be adding this point. Okay, let's assume it's an off by 1. That would be index 4. This would be index 20. Yeah, so maybe I do want to be up here. Okay. Now, let's remove this. Okay. It wasn't off by one. I was vastly overthinking that. It seemed odd that it was an off by one, but I now get why it was an off by one. All right, time to test the input. Brute force. Oh wait, nope. Right. Numb bites. Brute force. Away. Mm. It's possible it was just an off by one, and it's literally -1 here. But I don't want to tempt it since I'm running the brute force thing, and it shouldn't take too long, honestly. Like what, 32 seconds last time? Oh, also, I need to add in the coordinates. All right, there we go. I want to figure out a better solution, but um, my thought would be like, is it something where you can do like polarity of like go row by row, and so long as at least one row, if you start positive and every time you hit a wall and then followed by a gap, you go negative. Is there something you can do like that where like you can? I'm trying to think if there's any counter examples that I can just think of off the top of my head. That might work. But all right, I'm not gonna attempt 17. I'm too tired right now. Sorry. 17 part two. I think I have an idea of how to approach it, but I don't want to rewrite my 17.1 code, and I didn't push it, so I don't have it with me. So maybe tomorrow. Take care.